Let's go through LeetCode 787. Cheapest flights within K-stops. And for this question, it have give us n. That means that is in cities, and the person is coming from the source to the destination, and he can wait at most K-stops. For example, from 0 to 3. 0 to 3. If k equals 1, right? Then the cheapest that is this one, right? It's going to here and here. So we'll say k equals 1 and the source and that's so that means he visited 1, 2, and 3, right? So, and also for this question, it give us an two-dimensional array that is flat, and for each element, it has it is also an integer array. It has 3 elements. The first one is 0, means city from, and 1 is city to, and cost, right? That is from 0 to 1. It costs 100. So for this question, what I was thinking about is that we need to have a graph that is for every we'll say this is some kind of directional graph. That means it has a root from 0 to 1, but does not have a root from 1 to 0, right? So we need to create a graph that is from 0. This is a key, right? Key will be the source, and the destination will be the value will be, for example, if it is 1, then it will cost 100. And for example, the key, if it is 1, right, it can go to city 2 and city 3. So it will be 2 will be 100, and 3 will be 600. So we are going to use a map, and the key will be an integer, and the value we can use a list of int array, and this int array it has 2 elements. The first element will be the destination city or to city. Let's distinguish with this destination to city, and the map, the key is from city, and the list of int array, the first element is to city, the second element is from to cost. So what we are going to do is that we can create an int array called distance. For this one, initially, we are set this size will be new int n, right? Initially, we set this value to be some kind of infinity number, some big number, and we use a queue and put something like a node, right? Node into it. For this node, we can have an int array. The int array, we are going to put 3 elements. the first element is current city. The second element is the current cost from the destination, from the source to current city, the cost, total cost. And the third one will be how many stops left. And we use like some kind of we know for BFS we can use the weighted array or weighted stat. We can also use this kind of distance array. So every time we pull an element from this queue, right? And we use a graph to find its child or its next cities. We'll find if current cost plus what we get is from, for example, current is 1, right? And from the cost from 2, right, is smaller than the destination, the distance array of 2, right? Then means this neighbor we can enqueue again. Someone is asking, there are two kind of conditions. One is cost, another is how many steps left, right? So why we just compare one is enough. So theoretically, we should have two conditions to train some kind of values. Let's write this down. One is that the stops left is greater equal to the one we already calculate. Another is if the cost go to the next is smaller than the distance of the cost, or we already calculate the previous minimum. Then we can use the new one to replace the old one. But why we do not compare stops? Because if we use queue, right? We use queue. We know every time we go to next, the steps. We have more steps, right? We already go more steps. So we mean when we pop up the element pop from the left, the stops, which is stops, were always smaller equal to the one on the right. So this is the thing. We use queue. We don't need to worry about the cost. We just the stops. We just need to worry about the cost. That's enough. So let's begin to write code for this. Firstly, we want to have a map. As we talk about, we use integer as key, and this integer array will be the value we call graph. So let's reverse. This will be the from. We already have k. Use L. Goes to new array list, and we are going to add new int. Flight 1, flight 2. This will be our graph. And we're going to use an int distance. Plus new int and going to use a private static final int lineup next one. Let's shift it to the right for 2, right? Let's have this arrays fill distance. Okay. So we're going to use Q. And we're going to have Q offer new int. Let's say the first one will be a source, and currently from source to source we do the cost is 0, right? And we visited the 0 cities. And we'll say distance source that equals 0 because it is from itself to itself, right? So Q, we'll say while this Q is not empty, we'll have int, we'll say node, right? Equals Q dot full. So we'll say current city equals node 0, right? And the source to current city, the cost, we'll say let's say distance or the cost from the source to current city just the right cost node 1, and how many steps we have stops equals node 2, so from if we'll say if this stops equals it 1 stop, 2 stop. If it equals k plus 1, right? Then we cannot wait anymore. So here the k is just in the middle. How many stops? But to the destination, we'll have 1 more, right? So we'll say if stops equals k plus 1, we cannot go to any chart anymore. For example, if we go this route, we have 1 stop, right? And for this one is destination, we go to the second one. Then we cannot go here anymore. Then we'll have continue. Also, there is some kind of scenario is that for some of the cities, it cannot go to other cities. For example, these 3, right? If we visit 3, we cannot go to 3 to any other cities, cannot go to 1, cannot go to 2, or go to 0. So in this case, this city does not have a key in this map. So that means if map does not contains key, right? Graph contains key. Bound contains key. Right. We'll also continue. So, so now from we'll have this one, right? List of we'll say this is neighbors, right? Our children. Equals right 8. So let's say for neighbors, if neighbor one plus current cost, this cost. If this one is smaller than distance, neighbor 0, means we find a shorter route. Then we are going to have distance neighbor 0 equals neighbor 1 plus cost. And also we in this case we have the Q offer U int neighbor 0, right? This is the next city, and yes, we use this a lot. What's the next, right? Close. Neighbor, okay. It's neighbor. It's the neighbor. And in this case, we know we go to its chart, the stops. We'll have one more stops. Well, stops plus one. So in the end, what we are going to return is that it's still possible that for this distance array, it is still infinity. So if it is still infinity, then we are going to return -1. Otherwise, we are going to return